Hello dear viewers, today I'm going to show you how to design a G plus 4 building in Etabs. I prefer Etabs 18 because I have a compatible CSI details, although I have all of them 16 and 20, but we're going to design here in Etabs 18. So this is the architectural plan. I'm going to show you how you can model this building in Etabs, assign loads, and do analysis. And I'm going to share a lot on how to design appropriately using the Etabs software. So make sure you watch this video today. And so I'm going to close these two extra tabs. So the first thing is obviously to do the general arrangement. That is to determine where you're going to place your columns and your beams. Okay, so these are walls. These are walls from the architect, but this does not suggest that these are beams. These are basically walls. But obviously walls have to be supported by beams unless it's a partition. So you are the one to decide which is partition and which is not, and where you're going to place your beams. The other thing is the positioning of your columns. So first, can we start by scaling this drawing, because I'm sure this drawing is not to scale. So I'm going to go to home, linear. I want to determine the distance between this point and that one. So I'm going to also activate that. Make sure. Okay. So you need to scale this. I need to activate my calculator. That is 700. So the actual distance should be that 700, but it's currently 0.4 millimeters. So if you check the units, DWG units, you should make sure that your current units are in millimeters. All right. So my current unit is 3. You can see that cursor is 3, which means that we are working using millimeters. So this is okay. So therefore, I'm going to determine the scale factor. So my scale factor will be that 700 divided by 0.41. So this is my scale factor, 9,000. So I'm just going to copy or cut. Okay. And then select everything, scale, select the base point, and then type or paste the scale factor. Enter. So now it's still not to scale. You can see it's 3730. So we need to make sure that it's that 700 exactly. So again, calculator. The new scale factor should be that 700. Now divide by 37. That 730.88 is equals. Now this is our new scale factor 0.97. So I'll just cut and then scale. Select everything, scale, and then base point, and then type all paste. Okay, my base point is there. My scale factor is that. Okay, so now it's up to scale. The other thing now is to change our dimension. So type the dim style. So dim style, we pick dim style. Then the current dimension, we can just modify. Let my height be to that, my text height. My arrow height be also to that. All right, so text, um, my primary units, I need precision to be 0. Then click OK, then close. Now this is a lot better. Now I can just drag it there. Okay, so after that, now we can determine the position of our columns. So the first thing is, you know, that our column should be in all the four corners. Okay, the other position where you should be having column is where the intersection of walls and beams, because the column's purpose is basically to transfer the load from the slabs, which goes to the beams, and then to the columns, then to the footing or the footing, and then finally distributed to the soil of the foundation. So you can do, before you place your column, you can do the precising. So you can use VS spreadsheets to do preliminary sizing of columns. But for me, I already did that. So I think or we can just guess. I think the minimum should be not less than 225 millimeters each. That is about, I think, 8 inches. So I think we should, I will just go for 250 for this. You can see I have how many floors? First floor here. I have the second floor, the third floor. This is the ground floor, not first floor. First floor. Okay. Second floor, third floor. So actually this is the first floor. This is the ground floor, first floor, second floor, third floor, which is we have 3 water tanks, 10 liters each, and the fourth floor, which we have 2 water tanks on the top of our staircase. So for these columns going up to the second floor, I will do the general arrangement using this second floor. So for the columns going up to second floor, I will use a size of 250 millimeters by 250 millimeters. That is about 9 inches each. And for this column going up to fourth floor or third floor, I will use 300 by 300 millimeters. That is about 10 inch by 10 inch each. So so, sorry. I want to draw my column 300 by 300, so I'll pick this rectangle, type 300, comma 300, hit enter. Right, this is my 300 by 300. Then again pick this 250, comma again 250. So general arrangement is very important. So I'll change the color to green, and then I will hatch solid. I'll pick my color as red of this color. Then pick objects. Yes, you can either hatch by picking internal points of objects. I prefer picking objects. If you pick internal points, I face you can see it's already, so I select objects. Then I'll activate my just geometric center and check all these apart from intersection. Then I want to place the position of my columns. So this hatch, I should ungroup it, or let's see, I can be able to group. Um, let me remove this hatch again, enter, and then again. So I don't need to group the hatch so that I can pick this separately. Copy, okay, and check this. And please, my columns. I need to uncolumn there. One column there. So we do. I said we do general arrangement using this second floor plan. Okay. So remember, we have a water tank on top of this staircase. So we have to have columns in all both four corners of this. It is a must, not a request, because what is going to support that water tank slab and the water tanks load. So let me escape. Cancel. We must have water tank there. We must have a column there, not water tank, for a column there, and also at this point, and also even without that water tank, staircase is very critical. So it's important that you try to make sure that you have columns for both landing one and landing two to support that staircase. So I will also do this is basically water tank, and there's also water tank around. There's water tank at that floor, if you can see here. So I must have 4 columns at this point to support that water tank. So I will have a column there and there, all the 4 corners. I also need another column here, another column there. Finally, another column at this point, and at that point. So we can mirror the design. So I'll explain later. Let me first add columns in these points. So this is the position of my columns. Considering, and remember, we had this column 300 by 300. So these columns are the ones coming now at these points, because now these points are holding the water tanks, and also they are going up to the third and fourth floor. Oops, so let me undo. We need columns, copy. At this point, that point, that point, and that point. And then similarly, these points need to be columns. Yeah. And finally, yeah. Okay. So I just need to move this, move around the midpoint to that point. Okay. So now we can go ahead and model. So we have to determine also the place where we're going to add beams. So obviously I prefer my beams to be primary. Primary beams basically means beams that are transferring the load from slab directly to the columns. So in this position, I should maybe have a beam here and a beam here and also there and there. But this can be a partition wall. I also have a beam. So copy. Let me just finish doing this. Don't ignore anything. So I will also need a beam here. A beam here. This slab is very critical. Is the biggest, largest panel. So I'm having those called columns, and also I will need a beam. So this can be a partition wall, but I'll need a beam here, right? Maybe here we can add maybe a secondary beam to support that partition wall. And also now the other thing, we're not going to model the whole of this building because there is similarity, so we can mirror the design. You can see if I draw a polyline to this point, um, or I need to draw a polyline, not arc, a polyline from there, there, there. If you can draw this polyline, you will realize that so let me just draw the polyline so that you can understand what I'm trying to say. Back to this point, that, enter. So if I pick this polyline, you can see this building going this way is similar to uh, the other side, right? So we can model this building up to this point, and then we are going to mirror the design of this side to this side. Only don't forget that these columns and these beams have to be similar to this and these columns also. So this beam is not at the edge, or rather it's also supporting this slab here. So don't forget that when you're mirroring the design. So you're also going to mirror the design of these columns and these beams here, and the rest you can just mirror because these columns are also at the edge. So before I go to modeling, I will need to find the dimensions of spacing column to column. Okay, so I will turn on nearest, then turn on these 90 degrees. Okay, that's 700. Then I can go to annotate and continue. 2600, 1500, that into 5, into 5. All right. Okay, now again, we already have this dimension, that 200 and 5100. So we can go straight to modeling this in Etabs. So I will model halfway. So if I come to Etabs, I will start a new project. With a new project, I'll use build setting, units, metric, BS. We don't have any steel section. We don't have steel design. PS 8110. But either way, we can just change to BS. No problem. BS shapes. Okay. So I will use custom grids. Um, number of story is definitely typical story height is 2.85. Bottom also 2.85. 85. I have 4 stories, and then I will go to edit grid data. I will use display as spacing. So A, B, C, I'm having 3.7, 2.6 because it's in millimeters. Spacing A 3.7, B 2.6, and then C 1.5, 1.5. So here I can add 1, 2, 3, 1.5, and then um, then from 1.5 we're going to, now if you add this, or if I just go to linear, this is not there. This is 2.65. 2.65 under here. So remember, even when you're doing this, you're designing halfway, make sure you follow or you stick to the architect's plan, because the architect is always right. Assuming that even these columns are in the perimeter wall, you cannot afford to increase these dimensions even a bit. So I can just assume that this 2.6 is similar to this 2.6, and then this 19, when carrying it here, will be just amounted to 1500 and 1. So, but we just use 1500. Either way, this dimension and these are very similar, because it will not much affect the design of having a beam or a spacing of 14 and a 1482 and 1500. So we can just use here 1500. So either way, when you're doing a model, we are doing detailing, you see this 1500. If you use 1500 here, it has been covered for this here. So then 1500, 1.5 meters. Then we can just delete this last one. So these we have only 2 grids, that is 3.72 and 5.1. 5.1. This one does not exist. This is 5.1. Okay. So I will start at grid 1. Um, so this one should be the one to be 5.1 and then 3.72, so that I don't get confused. Then okay, then just click okay. Now I will just move to story 1, then start to do my columns. So I'll go to define, then define materials, Modify. This is steel. This you can modify. Concrete. So I can go to material, add new material, Europe, concrete. All right, so I will pick that concrete and okay, so that I can be able now to, then I will add Europe, rebar, and then okay, and okay. Then I can go to define section, frame section. I want to define my concrete column. So I will modify, and then I have this column of 250 by 250. These which are going up to the second floor. I'll use class 20 over 25 and say is concrete column 50. Then you can modify that. You can modify this. Just check reinforcement, concrete, then change this on to rebar. Okay. So my longitudinal want to be 16, corner 16, and then number of longitudinal bar along there's 3 and 2. Okay, confinement bar is T8. Then okay. Then I will add copy of properties now. Concrete column 300. Again here 300. 300. Show modifier. I just leave the modifiers. Just leave all of 4 columns. All of them is 1. For rebar, then just like that. Okay. Then let me modify this so that I will have 2. Then for concrete beam, I will modify. I'll show properties. My depth is 450. Class 25. My width is 200. Now the modifier here for the torsional constant, make sure that you release torsion moment or 99%. So torsional constant has to be 0.01 for beams. This is very important. Otherwise, your beams will be failing, and when you do manually, they pass. Now because you did not modify this torsional constant. My rebars I will use again rebar. Cover, my cover is 25 or 25 or 30, so 25. 25. Now make sure this is beam. Again, just like that, and we are done. Add new property. So okay. So I can go ahead and draw my columns. Then just change this to this column. Just in this point. Now let me first show you something, because don't want to be here. So edit, Edit story data. Where is edit? Edit story data. Modify show story data. Now this time I will pick this and say this is my master story. It's not my master story. Similar to story one. Okay. And so that if I pick, no, I want to similar stories. I pick him. Now it goes up to the second story. So let me undo what just did, then just place it there. There. Mm. So now we can go to beams, draw beam, that point. Now change this one to frame concrete beam. You can see what is just happening there. Guys, click release and just pick there and there. So now we can go ahead and add our slab. Now, if I can go to define slab sections, slab one, modify. My depth is 150. Shelving material class 25. Slab material. You can modify properties. Okay. Okay. Now this time, okay. Now, this time I'll go now to define. I'll go to define story data or edit story data, modify or show data. Again, this one is similar to story one this time. Okay. Now I will again now add my columns. Now checking here all similar stories. This point going up to story 3. That point. I'll go to plan, story 1, apply, close. So this time add columns. So this need to be deleted because I did not change the column. So I'll go add. Make sure you change this one. Now this time to the other column, 300. So I can just drag up those points. Okay, now this time I'll go to edit, um, edit story, modify. Now this time all stories are similar. Story one, which is a master story. Okay, um, now place my these columns and that's columns. Okay, then can add my beam, change to concrete beam. This concrete beam is okay. So this time, that point, that point, that point, that point, back to that point. Then I click to stop it. So this time I'll go to edit story, modify. This is similar to none. Okay, so that I can now add these beams up to that floor. Okay, up to there, back to that point. Right click to release. I'll come here, there, then back to that point. Okay, so I can go ahead and now add my slabs. Slab one. See, it's being repeated up to that floor. Okay. I'll go to edit, story data, modify. This is similar to none. Okay. Okay. Now this time I need to draw at this point. So I'll change back to this. That point is going up to second floor. Right click to release. Okay. So again, you can draw our slab. Okay. Now we can go ahead and model our staircase. All right. So I will go to draw, snap options. I want to start snap at line ends and midpoints. Apply, close. So if we go to this 3D, or can we close this one and then just go to 3D? Okay, we need to draw our first landing. Our first landing is uh, let me pick my beam at that midpoint. So I want to draw using this beam where I can draw up to 3D. So pick concrete beam. Okay, so I'll just delete. I don't need that. Okay. All right. So I need to pick beam. Release that point, the midpoint, and I want to select this beam. All right. So edit. I want to copy it in the y direction, duplicate in the y direction. My y direction is 1 meter. Number 1, apply. Okay. Then again I will draw another one here. Okay. So I can pick my flow, draw it from here, there, yeah, back to that point. Holding shift and pressing scroll button to rotate. And pick here, midpoint there, and back to this midpoint, back to the original. Again from that joint. All right. Remember, my similar story is up to story 2. That joint, that point, that point, that point, back to original. So so I will just pick similar to this just one story. Then I want to delete. Okay, escape, just this, and delete. Let's model this again from that joint. That midpoint, that point. So I want to pick slab, that joint, midpoint, that point, back to original. So now we have been able to model our slab. So this, I'll go to similar stories. Okay. And pick this, delete. Then pick this beam, delete. So now we can just go to all stories. Now we let me first add my roof tank, one story. Then remember I'm holding shift and pressing the scroll button to rotate. Now I want to draw the roof tank here at our staircase. Okay. Again, I now change to all stories. So I want to add my loadings to my um, flows, that is the dead and live load. So I'll go to define mass. Okay, so I'll not modify, define load patterns. I have dead and live load. Okay, so a self weight multiplier of 1 means if I add dead load, it's include its self weight. What else? Okay, then I will add. So I'll go to assign shell load info distributed. So let's go to the plan view. Story 1. Remember, now this time we're adding to all stories. So I want to assign shell uniform dead load of 1, that is for finishes, 1 kilonewton per meter. Apply. So I will need to select, let me just first close. I need to select all my slabs. So I'll go to select property or object type. I will select flows, select close, then go to assign shell uniform 1, apply. I'll assign live for room. Now this time, got to be careful. Similar stories. Remember, I only have 2 flows. So I'll go to assign shell uniform live load 2.5 for rooms, and the gravity direction, apply. Okay, so I have not selected anything, so I'll go to select, pick all of this. So if I go now to 3D view, they have been selected up to second floor, and I'll go to assign shell uniform 2.5 live load, apply. Okay, so again now I can select now these top stories. I'll assign shell uniform live load just 1.5 for the roof and water tank levels, apply. Now we need to determine the water tank load from uniform distributed load on this slab from the water tank. I have 3 water tanks here. So considering I have 3 water tanks, let me measure the distance between, because dimension will help us determine the uniform distributed load. Again, from this point, just 0.72 cancel. So I want to determine the uniform distributed load on these slabs. And on this slab, due to the water tank, our water tank has capacity of 10 liters. Remember the density of water is 1. So if the water tank, each water tank has a capacity of 10 liters, it means that let me pick text. It means that, so 10 liters, 10,000 liters, that is 10,000 liters as 10,000 liters. Okay, it means is equals to 10,000 kgs. Now we can change this to kilonewtons by multiplying by 10, that is the gravity, divided by 1000. You find that each water tank has a load of 10,000 of 100 kilonewtons. Now the uniform distributed load, so there are three, it means 300 kilonewton. The uniform distributed load will be this divided by the area, that is divided by 5, around 5.6, multiplied by 3.72, which is about 14 kilonewton per meter squared. So this is the load we are going to add here and also at the top. So I'll go to assign. So I'll need to select this first of all, and then assign shell uniform about. So I'll go to that. I think it's dead load 14. Do not replace, add to existing this time, and then apply. Okay, then close. So the other thing is to come here. I'll pick all of these nodes. So let me escape. I want to pick all of these nodes. Then assign, joint, assign, joint, restraint. I want to assign fixed, then apply. Close. Because the columns are fixed to the ground. All right. Now this time, I need to select properties, select slab, select. Holding control to uncheck this. Okay. Now I want to assign joint diaphragm 1. Apply. So let me select object type. I'll select flows. Select. And then uncheck these. Then assign joint diaphragm. So now we can go and run our analysis. Save as Madai analysis. I will save onto that location is okay. So as I've said, we are going to mirror this design to this other side. So we can check show deformed shape. We did not create combination. Let me first uncheck. So I'll go to define load combinations, add default combinations for concrete, then beam, frame, okay, then okay. Then again, run analysis. We need to make sure that we are designing for the load combinations to get the ultimate design. All right, so if I go now to these combinations, apply, okay. Now let's run concrete design. As you can see, all my members are passing the design check. Let's see the columns. And remember, this was to check. We were checking um, not designing. So we already used, I think, 2 T16 and 3, and 2 T16 and 6016 for the 300 by 300. So if I click details, you can see this design is passing. So you can go to concrete, verify all members passed, all concrete passed the design check. So you be careful. If you have noticed, we do not assign the wall loads. So why have I not assigned the wall loads? So first, if I can use another work we did, I'll go to desktop. Let me search some reference from Engineer Gituo. This one. Let me open these calculations so that I can explain why I have not added wall loads or partition wall. First of all, this building is in Nakuru, and the rocks were obtained from Bahati Baro. Those rocks are always considered to be load bearing because the crushing strength is more than 7 kilonewtons. So if the wall is load bearing, then you need to design a strip foundation because that is the one which is going to carry the capacity or the weight of the wall. So the wall should transfer its loads directly to the foundation, that is to the strip foundation, and not to the beams. You should not load your beams with partition wall if the walls are load bearing. If you can see here, first we have this strip foundation. If you can see that the crushing strength of rocks Bahati Barrow pit is 7 kilonewton per meter squared, hence the wall will be considered to be load bearing. Now, if you go to beam design, you will notice that the way we did this is that the beam load shall be from slabs and live load only. So there is no partition wall anywhere. It's only from the slabs and live loads only. So we're not going to uh, 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 assign or to add partition wall loads. That will lead to what we call over design. If am I not forgetting anything else, I'm going to the roof now. If you can see the plan, I'm sure this is a room. Now these columns obviously go to this point, and then our roof at this point, and then our roof is at the same level with this water tank. But considering we don't have snow load in Kenya, and the wind load, this is not a high rise. I think the roof load is negligible. It's very minimal, and therefore we do not. I don't need to consider it in analysis. However, when I'm detailing, I should not forget that this column is going up to this roof level. Then you can go ahead and do your detailing in CSI detail. You can go ahead and design the footing in CSI safe, and I have so many videos on how you can do that. So this will be the end of this video. Guys, if you like my video, please do consider to subscribe to my YouTube channel. I will see you in the next. So I decided to create this video for people who have Etabs software so that I can be able to share my concept and my idea on how to use this software in a smart way. Thanks for watching. I will see you in the next video.